Okay, use properties of logarithms to expand each logarithmic expression as much as possible. Where possible, evaluate logarithmic expressions without using a calculator. Okay, so for the first one, notice I have a quotient, log base 6 of 36 over the square root of x plus 1. So I'm going to use the quotient rule to expand this. This would be a log base 6 of 36 minus log base 6 of the square root of x plus 1. Now, one of these logarithms I can evaluate. The log base 6 of 36 is asking for the power of 6 that gives 36, and that's just 2. So the answer to this is 2, because 6 squared is 36. Now, minus log base 6 of the square root of x plus 1. Well, the square root of x plus 1 is the same as x plus 1 to the 1/2 power. So I can expand this or use the power rule. This would be a 2 minus, take that 1/2 power in front of the logarithm, log base 6 of x plus 1. And there's no property that lets me expand the sum in an argument, so this would be my answer. Okay, the next one, log of the 5th root of x over y. So the first thing I want to recognize, this is a common logarithm. It's the log base 10, but it's x over y to the 1/5 power. Whoops, I need to make a 5 there. So I'm going to use the power rule and take the power in front, 1/5, and then that's the log of x over y. And then I can expand this quotient. So I'm going to have 1/5 then times, and if I expand the quotient, it'd be a log of x minus the log of y. So that factor of 1/5 now needs to be a factor on the expansion. Now I could distribute that 1/5, but I'll just leave it like this. So for the next one, I want to take apart all the factors of the argument in here. So this is going to be equal to, well, every factor on top is going to be a positive logarithm. So in this case, I have the natural log. X cubed is a factor on top, so it's positive. Plus then the natural log of the square root of x squared plus 1. And then I'm going to subtract the natural log of x plus 1 to the 4th power. Okay, that's a factor that's in the denominator, so that would be a negative logarithm. So the rest of this, I'm just going to take down the powers using the power rule. Natural log of x cubed would be a 3 natural log of x. Plus, again, we have the square root of an expression, so that's a 1/2 power. This would be a 1/2 times the natural log of x squared plus 1. And then I'll take the power of 4 down, minus 4 times the natural log of x plus 1. Now again, there's no properties of logarithms that let me take apart additions in the argument, so this is as far as I can go.